So here we have a problem that we need Coulomb's law to solve. This is a point charge located at 103 on this 3D plane, and we have a charge Q2 which is also located at 0, 2, 1 on the same plane. These charges do not have the same charge. As we can see, this one has 200 microcoulombs, this one only has 30. So the first thing we need to do is we need to figure out R. R is going to be the distance between them. It's going to be given by the distance formula, which is the square root of each of these values subtracted from each other squared. So it's going to be Q1, or Q2 rather, minus Q1 squared, 2 minus 0 squared, and 1 minus 3 squared. These are all added to each other. This is going to give us a value of the square root of 9, which is equal to 3. Now, we need to figure out our r hat. R hat is the unit vector involved in this problem, and it's going to be r divided by r. Now, the differences between these two r's, this r is a magnitude, whereas this is just each of the coordinates. So each value here is going to be put over the magnitude, which is 3. Wow, 3. So it's going to be 0 minus 1, which is negative 1, plus 2 minus 0, which is 2, plus 1 minus 3, which is negative 2. And these really should be commas, because we're not going to be adding them. So this is going to give us an r hat of negative 1 over 3, 2 over 3, and negative 2 over 3. Now, we have the ability to plug this into Coulomb's law. Coulomb's law is F equals K, which is a constant, times Q1, Q2, all over R. And later, we're going to see an R hat. This is our direction vector. So F is going to be equal to 9 times 10 to the 9th, which is K, times Q1, which in this case is equal to 30 times 10 to the negative 6, times 200 times 10 to the negative 6, which is our Q2, all divided by 3. And this is going to be equal, plugging that in very quickly, to 6 times 10 to the 6th. And that's going to be newtons. Now, we need to find our direction. This is done by multiplying F, which is our magnitude, times the r hat that we found earlier. So, what we're going to do is we're going to do 6 times 10 to the 6th times negative 1 over 3. That's going to be our x hat direction. Again, for the y hat, it's 6 times negative 6, this time times 2/3 in the y hat. Lastly, the z hat, 6 times 10 to the 6th, negative 2 over 3, z hat. And these three answers are going to make up our final answer. So plugging it in, it's going to be equal to negative 2 times 10 to the 6th x hat plus 4 times 10 to the 6th y hat plus negative 4 times 10 to the 6th z hat. And that's going to be our final answer. Problem. There's 3 point charges this time instead of 2. Their values are shown here. And now we have to find the force on Q2 due to Q1 and Q3. So we're going to split this up. First we're going to find Q1 on Q2, and then we're going to find Q3 on Q2. To do this, we have to find our displacement vector, R21. This is going to be 4, 2, 1, which is the coordinates of Q2, and we're going to subtract them from Q1. So it's going to be 1, negative 1, and 3. And this is going to give us 3, 3, negative 2. Then we have to find the distance. So R21 is equal to the square root of 3 squared plus 3 squared plus negative 2 squared. And that's all going to be equal to the square root of 22. This is going to help us find our unit vector. If you recall from the last problem, this is going to be equal to r over the magnitude of r, which in this case is 1, negative 1, and 3, all divided by square root of 22. That's going to be equal to 1 square root of 22, negative 1 square root of 22, and 3 square root of 22. Now we're ready to plug it in to Coulomb's law. So it's going to be F between 1, 2 is equal to K, which again is our constant, over Q1, Q2 times R12 squared. This is our magnitude, by the way. And then it's going to be times our R hat. So let's do that. F12 is equal to 9 times 10 to the 9th times 150 times 10 to the negative 3, because it's in milli, times negative 50 times 10 to the negative 3. Let's fix that. All over the square root of 22 squared times r hat. So now let's evaluate just the force. So F12 is going to equal to, once you plug this all into your calculator, 3.07 times 10 to the 6th newtons. Now we need to multiply this by our r hat. So we're going to get 3.07 times 10 to the 6th times each value in r hat. So it's going to be times 1 over the square root of 22, x hat, plus the same thing, times negative 1 square root of 22, y hat, plus same thing, 3 square root of 22, z hat. And that's going to be our final answer for F12. Now we need to find F23. And it's going to be the exact same process. So first we need to find our R. R is going to be equal to, let's write a 2, 3 under it. Four, 2, 1, minus 0, 3, 5. Again, these are our coordinates for Q2 and Q3. Subtracting them, we're going to get 4, negative 1, and negative 4. The distance, again, we're going to take the square root of 4 squared, negative 1 squared, and negative 4 squared. Computing that, we're going to get the square root of 33. Once again, we're going to plug this into Coulombs law. Or actually, first, let's find our r hat. So we're going to put r, which is 4, negative 1, negative 4, over the magnitude of r. So it's going to be the square root of 33. This is going to get 4 over square root of 33, negative 1, square root of 33, and negative 4, square root of 33. Now we're ready to plug into Coulombs. So let's go ahead and do that. K, which is 9 times 10 to the 9th, times each charge's value, which is going to be 100, times 10 to the negative third, and 50, times 10 to the negative third, all over square root of 33 squared. And you'll notice that this is a square root squared, so this bottom part is just going to be equal to 33 multiplied by our r hat. So what this f is going to get us is a magnitude of 1.36 times 10 to the 6th newtons. And then once again, we can multiply that by our r hat. There should be that there. So f of 2, 3 is going to be equal to 1.36 times 10 to the 6th times 4 over the square root of 33 x hat plus 1.36 times 10 to the 6th times negative 1 square root of 33, square root of 33 y hat plus 1.36 times 10 to the 6th negative 4 over the square root of 33 z hat. And these both are going to get our final answers. So I've gone ahead and I've calculated each of these values just using a calculator because to find our f net, we're going to need to add them together. So our f net is going to be equal to f of 1, 2 plus f of 2, 3. So we're going to take our first x value, 6.5 times 10 to the 5th. Then we're going to take our y value, negative 6.5 times 10 to the 5th. And our z, 1.9 times 10 to the 6th. And we're going to add them to these other values that are over here. So it's going to be plus 9.5 times 10 to the 5th, negative 2.4 times 10 to the 5th, and negative 9.5 times 10 to the 5th. So we're going to add them just straight across, just like any other vector. And what we're going to get for this x value, we're going to get 2.92 times 10 to the 6th x hat. For the y, we're going to get 1.73 times 10 to the 6th. And for the z, we're going to get negative 2.26 times 10 to the 6th z hat. And this is going to be our final answer.